In this video, we're going to give you an overview of the thread milling toolpath. We're going to look at many of the options in the form and show the effects of different settings that you have on the toolpaths that you create. So what is thread milling? So this toolpath enables you to machine internal threads to create a hole that you can then screw a threaded bolt into. And you can create external threads for the exterior of a bolt, where it does this using specialist tools and a helical toolpath. So let's jump into the software and learn more about the thread milling toolpath strategy. And so to access the thread milling toolpath, come over to the Toolpaths tab on the right hand side. I'm going to click on this icon here, and that's going to open up the thread milling toolpath. So we're going to just walk our way through the form and just explain what everything means in here. So to start with, we need to set our cutting depths. So this first section here is where we specify all of the cutting depths, where we choose where we start from. Okay, so quite typically you're going to start at 0 on the top surface of your material. Obviously, if you've already pocketed or machined away some material, then you'd enter in the value at which you've created that recess. In this case, we're just going to go with 0 in here. Then next up, you've got the maximum depth that you want to cut into. And we're also displayed a thread length, which is actually greyed out here. And this is for information purposes, as it's calculated from the tool you are using and then the max depth that you enter. And so we'll have a look at this again in a second. Next up, we've got the tool. So this is where we select our tool. You can use the select option and that will open up the tool database. Now, there are two types of tools that you can use to create your thread, using single point tools or multi-threaded tools. Now, single point tools have a single point for cutting a single thread at a time, and multi-point tools have multiple cutting teeth and they'll cut all of the threads in a single rotation. Now, there are a number of advantages and disadvantages for using either. For example, single point tools provide us with more flexibility when it comes to the threads that they can cut, where you can vary the depth it cuts to allow threads of different pitches to be produced. Also, single thread tools need to machine all of the threads with one cutting edge, so it will be a lot slower to machine threads compared to the multi-thread tool that will cut all the threads in one single rotation. Now, once you've chosen your tool, you now need to enter the thread definition information, and this is specific to the thread that you want to cut. Now, at the top, we have a drop-down list of pitch presets that you can choose from one of a number of standard pitch presets. Now, the standards are based on the isometric thread standard for metric units or the universal thread standard for imperial units. And so selecting one of these options will pre-populate the pitch field with the correct value. Alternatively, you can define the thread pitch by typing in a value in the pitch field. And the graphic on the left highlights the pitch, showing you that this value is the distance between the peaks of the thread. Now, if you were using a multi-thread tool, then the pitch field will be greyed out as the pitch is defined by the multi-threaded tool that you are using. And we'll look at an example of that later. Then you specify the diameter you want your thread, where you enter in the major diameter, and that's the largest diameter from peak to peak. The fit tolerance controls how tight a fit the thread will have, and so setting a positive tolerance will mean that the tool cuts a slightly deeper thread, and so in almost all practical uses you would definitely enter a tolerance in here in order to get a thread to run smoothly. Next, you can choose whether you want to create an internal or an external thread type. And then choose the thread and cut direction, so whether that is left-handed or whether it's right-handed. And the cut direction determines whether or not we want to machine the toolpath by spiraling downwards or upwards. Which direction you choose will depend in some part on the relationship between the spindle direction, the tooling and the desired finish. So that's a brief overview of the form. So let's take a look at an example where we can look at how to create internal threads. So for our first example, we're going to look at how to create internal thread holes using multi-threaded tools. Now in my design, I've got a series of 8mm holes that I want to machine with an M8 threaded tool to create M8 holes. So I'm going to select the vectors that we want to apply the thread to first, and it's worth pointing out here that the vectors that you use to create a threaded toolpath are purely for location purposes, where it will create the thread from the centre of the vector regardless what shape it is, and the thread diameter is specified in the form itself. So back to the top, we're just going to set our start depth at 0, which is the top of my material. Now before we look at the maximum depth and the thread length, let's just select the right tool for the job. So using the select option, let's just open up the tool database. And then we're going to select this 6mm M8 tool. Now here we can see all of the relevant information about the tool itself. So we're working with a 6mm diameter where each tooth is 60 degrees. And your tool provider will be able to provide you with the correct fields that you need to enter in for the tool, so the pitch, the tooth size, the offset and the threaded length. And we can see that the thread length here is 15mm, and so this is the maximum thread length that we can go to. If we exceeded this in the cutting depth section of the form, then the software will inform us upon calculating the toolpath, prompting us to enter a safer, more suitable maximum depth. Right then, let's just talk about pass depth. Now, it's worth bringing up here that the pass depth for thread milling refers to the sideways passes that the tool has to make to reach the full thread depth required, and it actually has nothing to do with the vertical depth, as you'll see in all of the other toolpath strategies. For this particular tool, the pass depth is set according to the tooth size in the example tool that we have here, but as always you should ensure that the tool is set up so that it's safe and appropriate for the material that you're cutting into and the machine that you are using, and this also applies to the feeds and speeds also. Right then, max depth. So this is the maximum depth we want to mill down to, and this mustn't exceed the tool's thread length. Now we can go ahead and choose our maximum depth. For example, let's put 5 in here, and you'll see that our thread length also changes as well, and this is all dependent on what we put in here. Now, as we mentioned earlier, this maximum depth cannot be any deeper than what we have in our tool definition, and so if you forget what that is, it's always good to go and check your tool to make sure. For now, we're just going to keep our maximum depth to be 10mm. Moving on to the thread length. So thread length is the number of full threads or loops that will fit into the maximum depth and taking into account tool offsets. And so at this depth we can see that the tool's thread length using this M8 tool would be 8.75mm. And you'll notice that our thread length is less than our maximum depth every time, and that's because the thread length is the number of full threads or loops that will fit into the maximum depth, and this will always be less than the maximum depth, seeing as it takes into account the lead-in and also the base of the tool. Now, we've already selected our tool, but if we wanted to make any temporary edits for this toolpath, we could go ahead and click the edit option here to make temporary edits to this tool in this particular toolpath, and it won't affect our master tool set. Then we move on to thread definition. Now you'll see that we can't choose a pitch preset, and that's because it comes from the multi-threaded tool. The same with the pitch, this is greyed out as all of this information has been defined from the actual multi-threaded tool. Now the diameter is actually the hole that we're going to create, so we're going to make that 8mm because we want this to fit an M8 threaded insert. Next up, fit tolerance. So this controls how tight a fit your threads will have, and so setting a positive tolerance will mean the tool cuts a slightly deeper thread. It's good practice to add a slight tolerance in order to get the thread to run smoothly, and so you may want to consider running a series of tests, and that will help you find the sweet spot. And this is very similar to the concept of applying allowances to slot together parts or inlays. And seeing as this is just a demonstration, we're just going to leave this set to 0 for now, but it's important to know that you do have this option to use in a real world application. Then we move on to this button here to create circles for internal threads. And this option creates the correct geometry for us to use to create a circle for internal threads based on the diameter that we've set for the thread in the form. So using this option, the software will go ahead and create us a set of circles inside of the circles in our selection using an offset, and that offset will be calculated based on the tool that we're using. And then we can safely clear out these internal areas with the pocket toolpath to ensure that our multi-threaded tool can fit in there and do its work to establish those threads. So let's just take these vectors, I'm just going to hold shift and select those newly created vectors. We're going to right click, say move to layer, new layer. We're just going to call this one pockets, and then we'll give that a colour just so we can see the difference there. And then we'll just go in and just reselect our external thread vectors to apply that back to our thread milling toolpath, and we'll come back to the pocket vectors in a second. So then we've got our thread types. Obviously we are working with an internal thread, and if you was working with an external, you'd switch to external. So next we move on to thread direction. So we're going to make left-handed threads so that the thread direction will be left-handed. That way, when we turn in an M8 insert, then we'll end up turning that anti-clockwise. So we're going to use the left-handed option, and we're going to look at the cut direction going from top to bottom. And then what we can do is we could go ahead and give that a name if you wanted to, and then we could press calculate. And then the software will open up our preview toolpath dialog, where we can then go ahead and preview our toolpaths to make sure that they look okay before we run them on our machine. For now, we're just going to go back to this, and what we're going to do is we're going to look at creating our pocket toolpath first using those pocket inserts. So we're going to just select our vectors by double clicking on the pockets layer at the top here, so we can see that they're currently selected. We're going to go into the pocket toolpath. Okay, I'm just going to remove all of these tools that we've got in here. So we're going to set our cut depth here to 10 millimeters, and we're going to use the select option to open up our tool database, in which case we're going to then choose a tool. So we're going to choose a 6mm tool. I'm just going to select that and then just leave that as pocket, and then we'll go ahead and press calculate. And then what we could do is we could preview this toolpath. So that's our pocket. Okay, so it's created these holes for us. And then what we can do then is safely go in with our thread tool to create our thread toolpath. Now before we go ahead and preview that, let's just move the pocket toolpath to the top of our list to ensure it's in the correct order for when we go to machine this. And then with the thread toolpath selected, let's just go ahead and preview that. Okay, now our software can't actually render that toolpath type in the way that it would look in the real world. So we're going to have a look at a short video that will describe all of the different options that we have in our thread milling form in terms of the thread direction and the cut direction. And so in this first example, we're applying a left-handed thread direction from top to bottom. And you'll see, because this is a multi-threaded tool, it does it quite efficiently. Next up, we're going to be using a right-handed thread from top to bottom. And then in the third hole, we're applying a left-handed thread from the bottom to the top this time. And then in the last hole, we're going to look at creating a right-handed thread from the bottom to the top. So I hope that this video has helped you better understand what's happening right here when you choose your thread directions and your cut directions. So now we're going to look at another example, and this time we're going to look at using a single thread tool. So let's just close out here, and we're just going to save our file. And then I'm going to open a second example, which is example number 2. So here we have a set of 4 circles. Each one of those is at 1¼ inch diameter. So we're going to switch over to the Toolpaths tab. I'm going to select our vectors, and then we're going to go into the thread milling toolpath. So we're going to click on this button here. Okay, so we're going to work our way down the form again. So start depth, we're starting at the top of the material at 0. Maximum depth, well, let's just go and select our tool to begin with. So we'll use this select option over here. We're going to go into this tool. So this is our 60° 3/4 inch thread, single thread tool. Okay, so some of the things we need to just glance over, ensuring that everything's safe and appropriate, everything's plugged in correctly, and this has all been input as per the manufacturer's settings. So the important thing for us to remind ourselves of is the neck length. So 1.5 inches is our neck length. So we know that we can't set our maximum depth any more than that. Pass depth is 0.1624. And then again, as always, feet and speeds, ensuring that they're safe and appropriate for your particular machine, tooling you have available and the material that you're cutting into. So we're going to select this one. So we'll use the select option here. Now for the maximum depth, I'm actually going to put that in at 0.7 in here. And then we can see our thread length is currently at 0. So once we start plugging in some options within our thread definition, we should start to see a thread length displayed here. So going to pitch preset, so obviously we can go through the presets that we already have available. So we'll use the imperial ones at the bottom. And you'll see as soon as I put the pitch preset in, the pitch field has been pre-populated based on the data that we've selected. Now we're just going to go with a custom pitch preset here. So we're going to use custom, and then here we're going to set our pitch to be 1/8 of an inch. Our diameter is pulled from the diameter of the circles that we've got selected. Fit tolerance, again, we're just going to leave this at 0. This is just a demonstration to show you how the single thread tool works. And again, we want to ensure that we create circles for internal threads. So we're going to click on that and we can see these vectors here. So we're just going to take those. And again, like we did before, we're just going to move them to their own layer. So I've already got a layer here called pockets. We can see that there, okay. Right, and so we'll just select these again, just to ensure that they're in our selection for the toolpath creation. Then we're going to go with a left-handed top to bottom thread direction and cut direction. Give that a name and we'll just go ahead and press calculate. Okay, so we've got our toolpath ready to be previewed here, but before we do that, let's just go and create our pocket toolpath. So we're going to select all the vectors on the pocket layer by double clicking on the layer page here. We're going to go into the pocket toolpath. So here we're going to set our start depth at 0, and then our cut depth, we just want to make that more than our thread. So we're going to make that 0.75 in here. We're going to select our tool. So we're going to use the select option here. We're going to use a 1/4 inch end mill. And then we're just going to call this one pocket. And we'll go ahead and press calculate. And then what we can do is just move this up the stack. So we'll be cutting the pocket first. So preview that. So there's our pocket. And then because we've pocketed this out, it just ensures that we can go in safely with our threaded tool then to create the threads. So let's just switch on the thread toolpath and we'll just take a look at how this looks. So I'll just zoom in over here. Okay, just accidentally press the right button there. Okay, and then what we're going to do is we're actually just going to take the colour shading out just so we can take a look at the actual toolpath itself. So what's happening here is the tool is going to plunge down and then it's going to move out and start to go down to the start depth. And then there's this circle movement here at the very top, and so it's going to create a quick chamfer around the top of the hole. And the reason for that is it will help to create a nice seat for when we screw in our threaded insert. And it's also going to make sure that if there's any chipping that happens with our first contact, it'll be minimised, and then it's slowly going to work its way down in this nice helical fashion to the bottom. And then it's going to retract back to the centre of our pocket and then pull the tool out of the hole. Okay, so let's just put our colour shaded view back on there, and we'll just stick that to the top view, and then we'll go ahead and preview that. So again, we didn't really see much here because the software can't represent those undercuts that we're going to get from those threads. But what we'll do is we'll just take a look at a real world example, and we'll look at all of the different options like we did before. So here's our first example of a single threaded tool cutting a right-handed thread from top to bottom. Next up we have the same tool doing a left-handed thread from top to bottom. And then we've got a left-handed thread from the bottom going up to the top. And then our last example, we have a right-handed thread from bottom to top. And you can see the comparison between the two examples that we've looked at and see that single-threaded tools would take a bit more time than a multi-threaded tool would. So hopefully that gives you enough guidance for you to go on your way and create some awesome thread milling projects. Thank you for watching.